Good evening to everyone. Good evening, one and all. We'll wait 5 more minutes. After 5 minutes, we'll start. Now 74 participants are joined. Only 74 are joined. We'll wait 5 more minutes and we'll start. Sorry for the delay. We'll wait 1 more minute. We'll start the session. Okay, we'll start. Welcome back, everyone. We are now ready to begin session 1 of day 3 of our faculty development program on revolution of large language models in AI. Myself, Dr. Anusha Ampavati, coordinator of this FDP. So I don't want to waste my time. So just I want to give some general instructions to you. So today we have the 2 sessions will be there. The first topic will be fine tuning and then evaluation LLM by honorable guest and speaker Ms. Durga Devi Jami. And the second session will be on the topic of LLM prompt engineering by Mr. Shaurya Kushal. So now I want to give the mic to Ms. Shanti Priya ma'am to introduce our honorable guest of session 1. Thank you. Over to you, Shanti ma'am.
Thank you, Dr. Anusha. Good evening, everyone. I am Shantapriya Katta, Assistant Professor from the Department of Artificial Intelligence, VJIT. So today I want to tell about the session one speaker, Durga Devi Jami, is a seasoned IT professional with 15 years of experience in technology and innovation, currently serving as a technology lead at Broadridge. She has made significant contributions to various domains, including data analysis, software development, machine learning, artificial intelligence, and Azure. Her expertise lies in delivering innovative strategies and critical solutions that address complex business challenges. She began her career at Curvy in 2011, where she contributed to the mutual fund sector in the financial domain. focusing on the development and management of multiple products until 2014. She then joined Patra Corporation, where she worked in the insurance domain from 2014 to 2018. From 2018 to 2022, she was part of Deloitte Consulting Services, where she dealt with diverse domains such as manufacturing and the US government projects. Since 2022, she has been leveraging her skills in the financial domain at Broadridge. She is passionate for combining creativity with analytical thinking, drives her to design and implement impactful technological solutions, reinforcing her dedication to excellence and innovation in the IT field. Now, I'd like to invite Dr. Durga Jami of the session one speaker. Over to Durga Jami.
Thank you, everyone. No. I'm sharing my screen.
Yes, ma'am. You can, ma'am.
Are you able to see my screen, right?
Yes, ma'am. It's visible.
If anyone not able to see my screen, please let me know. So
Please watch on your video, ma'am.
yeah, sure.
Thank you, ma'am.
Thank you. Hi, everyone. This is Durga Devi. As already introduced by the ma'am, you know me, right? So so today's topic is fine tuning and evaluating LLMs. So So before starting this fine tuning process of LLMs, I want to introduce what is LLM. So in the previous sessions, we already know from the before days learnings what is LLM and how the LLM was designed and everything. So now I want to give a small brief introduction about LLM before fine tuning these LLMs. So as everyone knows, what is an LLM? LLM, we already know it is a large language model. And coming to the clear definition of LLM, it is a machine learning model based on advanced trained AI on a massive data set. That means it is a collection of different massive data to perform some actions based on the prompts and questions and different options given by the user. So for these LLMs, we are using a large data set, and the large data set is designed based on different machine learning technologies. Hello.
Ma'am, you can continue, ma'am.
Oh, sure. Someone messaged not audible, right? So that's the reason I'm checking.
No, it's audible, ma'am. It's very clear.
Yeah, sure. Thank you. So machine learning models based on the massive data set, that means large data set we are using to design the language models. So here we are using the technology of machine learning. In that machine learning, one part is deep learning process. In the deep learning process, by using the transformers, we are designing the large language models. Why these transformers are used, where it should be useful? The main concept involved in this transformer usage comes under the subset of neural network technology. So by using these neural network technology, they incorporated all the large data set into a single model, which would be helpful for the every user who using these application. Some examples of these models are, everyone knows, GPT-4, GPT-3, Dept, T5, and OpenAI, Llama, all these are comes under large language models. Initially these are designed, and after then they are customized into different subversions to perform standard applications as well. And how these LLMs mostly useful means, the live example is the chat GPT. And what are the features of these large language models are, the first, based on these features, why we are need to know about these features, because the LLM features are very helpful. So because of these features only the LLM get more popular. What are the main features of these LLMs are, the first one is data, massive data. What is massive data? That means every model used in the LLM having large data set. That means they are trained. That means they incorporated the large data set from the websites, different textbooks, different papers and everything. They collect all these data and used in this LLM. And the second feature, so because why we use these large massive data means it is used in different applications. So to answer all the questions, to get the required answers, so for these purposes the massive data set is very useful. And the second feature comes into the second feature. The second feature is contextual understanding. What is meant by contextual understanding, why this feature can be helpful in present in the LLM? So the contextual understanding means what we are giving. That means what is the user. For example, if one person using chat GPT, so the person gives the text, the content, whatever he knows or she knows in the prescribed English language in the general format to get the generalized and effective results. So based on the context given by the user, the chat GPT, the model which we used in the chat GPT, that is the LLM model, the model can understand that divides into segments and can understand the complete question, that means the complete sentence, and divided into different pieces, and it can understand based on these tokens, and it gives the exact more effective results to successfully accepts the user questions and given answers. So that because of that reason it is very useful, because every user so if you consider some programming languages, if we know that particular programming language only, then we use that application. So like not like that, the LLM model is the user acceptable. That means whatever the user given language, it accepts the language and it gives the results based on this context understanding feature. And generative capability, what is the generative capability? It is interlinked to the contextual understanding. That means by the given question of the user, it is having the generative capability. That means if you given half sentence, it can predict what is the next sentence, and it try to summarize the question, and it try to give the answers based on the generative capability. And the next one is wide applications. It, after creating these LLMs, it is used in wide applications by changing small tuning of these LLMs. It is used in different applications. If you see in the screen, I am sharing few applications, that is chatbots, translation summarizes, question answering, chat GPT. Like these different applications uses these LLM models based on their requirements. So that is one of the reason it is gets more popular, because of these wide application feature. And the next one is the most important feature is the transformer architecture. So mainly the LLMs are based on the transformer architecture. Already as initial I said the transformers. What is transformer? The transformers are mainly concept of the neural networks which comes into the machine learning. By using these transformers, the main model of the LLM is designed. Then what is the use of the transformers, why it is helpful for the models, and why this feature will be helpful to widespread of LLMs is the transformers is mainly The transformers are mainly based on the self-attention capability. That means if we given any text, then what happened is, based on the text, it is generalized the sentence. It has the self capability to generalize the sentence, and based on the generalization it will give the effective result. So that's the reason of the feature of transformer architecture. The LLMs have a wide role, wide feature capabilities, and it is widely popular in our life, real world applications. So how these LLMs works, and then first we know how these LLMs works, and then we move on to the fine tuning of LLMs. So how these LLMs work means, first, for example, if you consider the chat GPT as an example, then it will be easily understandable to everyone. So how these LLMs will work means, for example, if you want to know about any question related answer, one question. So what are the regions in our state? So if we want to know the question, so if we given the question, how this chat GPT will work means, first it will divide the user given question into token formats. Everyone knows, right, what is a token? It is a small parts of the sentence. So it divides the sentence into small pieces to understand the effectiveness of the question. And then what it does is, by dividing this into small tokens, it clearly understands the complete question given by the user. And then what it does is, it is analyzed the originality of the question and the effectiveness of the question. Based on that, it will understand the question given by the user. And then what it does was, it processes the question to get the effective answer. How it is processed means, it is based on the training process. What is the training process? At the design of the LLMs, they given prescribed trained data set, so particular income, and it will give a particular output based on the input given by the user. So that's the reason, based on the training process of the LLM, it will evaluate the effectiveness. That means what should be the answer of the given question. And then what it gives is based on the learning patterns. That means at the time of training the data, that means at the time of training, they injected the data sets into the models. So based on the data sets are injected, they have some learning path. That means if it should be the input, there should be a there should be a respective output for these. Like these few parameters are inbuilt in the model. So based on these parameters, they will give the effective result. So the main working part of the LLM model is, it is tokenization and the training based on the training data set, and it gives the learning based on the learning patterns, it gives the effective results. So coming to the main part of our topic is fine tuning. Everyone knows fine tuning means minimizing, that means optimization of the model. So why we need the fine tuning of LLMs? Is there any requirement to fine tune the LLMs? Because every model will work for general application. So why we need these LLMs? What is the use if we use these fine tuning model? Is there any usefulness for us? Yes, there should be a usefulness if we fine tune these LLMs. So what is the main purpose? As initially we said, LLMs are mainly based on large massive data sets, which means it is a data gathered from different websites, books, and everything. So because of this huge data, if we want to use for a particular specific application, that means if we want to know in-depth details of the medical application, or if we want to know the in-depth details of the legal related questions, so if it is a huge amount of data, it is a generalized data, we're not sure the LLM model gives us the accurate results. So that is the main reason the fine tuning of LLMs are comes into the picture. So there are few requirements to fine tune these LLMs. What are the requirements? So many members want to specialization to the specific domain. That means they want LLMs for a specific model only. So if we use the huge amount of data in a single model without having any data sets, so what happened is it is not given the accurate result. There may be a 50% chance. So that's the reason they wanted to specifically one domain specific LLM wanted to create. So for this purpose we are using this fine tuning process. And the second purpose is accuracy. We want to improve the accuracy process. So that's the reason, to improve the accuracy of the trained mission, we are giving the fine tuning of LLMs. And the third need of fine tuning the LLMs is efficiency and the cost effectiveness. It will give the effective result without any error faults. And the cost, if we use huge data to deploy that huge data, also we need large number of servers, large gigabytes of processing units and everything. So because of these reasons they want to minimize, that means to affordable to everyone, they wanted to fine tune these LLMs. And to if everybody knows English, that is better to use these chat GPT. If you want to specific any cultural alignments or any specific ethical related things, for this reason also they want to fine tune these LLMs. And if we want to perform on a specific data, this huge data is not required. So that's the one of the reason we want to move on to the fine tuning of LLM. Because all these consideration, we are moving into the fine tuning of LLMs by using the main LLM courses. So the next one is, as we know, why we need these fine tuning LLMs. So then we already knows that all knows why we need the fine tuning of LLM, as I initially said. That means for a specific domain purpose, for the cost effectiveness, for the improved accuracy. These are the main considerations to move on to the fine tuning of LLMs. Then what is fine tuning of LLM? Why we knows? Then what we need to do the fine tuning of LLM? First, what is the fine tuning LLM? For this process, first we know what is fine tuning. So fine tuning, everyone knows LLM is a pre-trained model. That means it is given a huge data set, and based on the particular parameters, hypothetical parameters given to the model, and based on the input and output data set, it is giving the results to the user. So it is having a pre-trained data. So what we did in the fine tuning process is simply, the fine tuning is we can take the pre-trained model from the LLM, and we can inject a new task specific data set. That means how we can do this? We are doing it from the scratch. That means already there is a pre-trained model, means it is having huge amount of data. Means we want to remove the overall data set and we need to incorporate a task specific data set. No, that is not the process of fine tuning. What we are doing is, we are not doing from the scratch. That's the reason we are taking the pre-trained model, and what we are doing is, what task we want to perform to fine tune this model set. That means for this LLM model, why we are using, for which purpose we want to change this LLM, language model. So based on these criteria, what we did is in the huge data set, we will take the subset of data, the task specific data, what was present in the pre-trained model, and we are try to change the parameter related to the subset of data set only. So by using this process, we are fine tuning the large data set, that means trillions of data set into millions of data set. So the speed of the LLM will increase, the accuracy of the LLM will increase. Because of this all fine tuning process, most of the successes are arrived based on the task specific. That means we are using only the subset. That is the fine tuning of LLMs. So what is meant by pre-training and versus what is meant by fine tuning? If you all know already, I explained LLM is a pre-trained model. So why we are using these pre-trained models and what is the differentiation of pre-trained model with the fine tuning dataset? So here, if we consider the pre-trained model, what happened is the pre-trained model is a huge data set. Both are different types of processes to build the LLMs, but the pre-trained model is designed based on the large massive data sets, and it is especially having huge amount of data. So it is built it from the scratch. So that's the reason it doesn't use it for a specific domain purpose or a specific task purpose. It is a generalized model designed initially. So what is the characteristics of this pre-trained model is, first coming to the main part of the model is data, right? So if you coming to the pre-trained model, the data is very huge and it is taken from different websites, different books, different papers, and it is used to design the model. And what is the objective of this data set? The objective of this data set is, it is used mainly to generalized purpose. It is used for the generalized purpose, not only a specific task or domain. And coming to the cost of these pre-trained models, it is using large set of models, large set of data. So because of that reason, the cost designed for this model is very high. So, and the outcome of this model, if you're coming to the outcome of the model, the outcome of the pre-trained model is general specific generalized outcome, not to a specific domain or not to a specific question. For example, if you ask any specific question, it gives the generalized answer, not in depth in the specific domain. So that is a pre-trained model. Why we know about this pre-trained model is the fine-tuning model coming from this pre-trained model only. Because of that we need to understand what is this pre-trained model. And the next one is fine-tuning model. What is a fine-tuning model? It is coming from the pre-trained model. So that means we take in the pre-trained model and we do some actions, and then it is moving into the fine-tuned model for a specific task or for a specific domain. So that is the reason of pre-trained and fine-tuning model. So how we can do this fine-tuning process? So that means we need to fine-tune this model, right? So because so what should be the steps we need to follow to fine-tune this model? So first, for this model, we need to take the pre-trained model, and what we need to do is we need to do some process for completing these pre-trained model into completely converting these pre-trained model into a fine-tuning model. What are the steps involved in it? This is the main key part of fine-tuning process. So I will explain step by step. Please listen carefully. So the first one is we need to define the objective of the fine-tuning model. What is the objective? That means we need to identify for which purpose we want to design the model. So first we need to have a clear understanding of what model we need to fine-tune from these pre-trained model. That is the first criteria in the fine-tuning model process. And the second objective is collect and prepare the dataset. So what from the massive data present in the pre-trained model, we need to collect which subset of data is required for our fine-tuned data model. We need to collect that data and we need to clean the data. What is meant by cleaning of data in the model means the data should not be having any errors and the data should not be duplicate. The data should not be irrelevant to the specific model what we are thinking to fine tune. So based on these details, we need to clean the data and maintain the data quality. So if we maintain this data quality, we will get the exact results of the data set. So that is the main criteria we need to consider in our first fine-tuning process. And what is the second step? After we collecting the data set, we need to format the data. After cleaning up the complete data, we need to format the data. Why we need to format the data? Because the model need to understand what is changing and what is the user given questions and which relevant answers we need to give. So for this purpose, we need to convert the data into the format of the LLM which the model can understand. So that is the main criteria. And so after all these dataset completion and which model we need to fine tune, then we need to configure the process. That means once we included the data into the dataset for a specific task benefit, we need to configure the process. That means after injected the data, we didn't confirm the data is good and our model is ready, so it is working perfectly. We didn't confirm, right? So that's the reason we need to validate few scenarios and then we will confirm our fine-tuned model is also working well. This is also comes into the fine-tuning process. So in this process, what we need to check is what is the learning rate of the fine-tuning model. That means if the user given a question, then how the model, our new design model, will accurately and quickly given these answers. So how much quickly it giving the answers based on the parameters designed by us. So where the parameters comes in, that is the formatting of the LLMs. While formatting the clean cleansed data, we given certain parameters to the model to quickly answer the user question. Based on that, the learning rate of the design fine tuning model will be calculated. So the first criteria we need to check is what is the learning rate. That means how quickly the model given the answers. And the batch size, the next criteria we need to check is batch size. What should be the data size we are using this fine-tuned model? It is also huge, like same as what we take in the pre-trained model, then there is no use of fine-tuning. So that's the reason how much data will be decreased and which less amount of data we are using and we are getting the accurate result. That is the main criteria of the fine tuning. So we need to check how the fine tuning will effectively gives with the less amount of data as well. And the third process is epochs. Why we need to check these epochs after incorporated the data into the model? That means first we know what is epoch. Epoch means what are the number of times we need to reprocess the data, entire data set, how many times we will process. If there is any issue while checking the learning rate, that means how quickly the data given the results, we are every time we will change the parameters, we will change the subset of the data, we will change the quality of the data. So that's the reason how many times we reprocess the data to get the fine-tuned model what we needed. So that's the reason the epoch is also one of the factor to fine-tune the data set. And the last one is select a specific framework to check the fine-tune model. What are the frameworks we are used for fine-tuning process? There are different frameworks used in the model. Those are tensors, pytorch, OpenAI ones. Like that, there are different processes. So all these processes we are using these fine-tuning, we are using in this fine-tuning process framework to design our task specific data model, large language data model. And after completion of these 3 steps, what we are moving on to is we are moving on to the deployment of the fine-tuning model. Why we need to deploy these fine-tuning model? Once we deploy these fine-tuning model only, it will be useful to everyone. So for this reason, to test this one as well, we will deploy this model into any of our application. That means we want to use this model like as a chatbot, so we can incorporate in our website to use it as a chatbot. So that is the reason we need to deploy this model. This is also comes under into the process of fine tuning. And after deploying this process, we can say that our model is fine tuned and it will be very useful to everyone compared to pre-trained model. We can't say like that. Then what should we need to do to confirm our fine-tuned model is very accurate and pre-trained? The final one is the process of validation. How we can validate this fine-tuning model? So to validate this fine-tuning model, already we are given some pre-trained data set and pre-trained parameters for the specific input. This should be the output. So how can we validate? There are certain rules to validate this fine-tuning model as well. What we need to do for this fine-tuning model validation is, first we need to give the real world examples. Take in the real world example and try to get the results from giving the question of the real world into our application chatbot, and we will check it is giving what the user thinks. That means the question given by the user, right? He or she expecting some results, so it is giving the accuracy. If it is not giving the accurate result, check what is the accuracy level. And then we need to check if we give the unseen results. That means what, for example, if you give some images to the pre-trained to the fine-tuned data set, so these are the some images of dogs, so these are the types of dogs we are having, and otherwise these are some types of machines we are using. If you want to ask any other type of machine which was not already given as examples in the parameter level, so what it should need to be, our fine-tuned model will generalize the result and will give the task specific data which is relevant to the question which was not initially involved in the trained model. Then only we should confirm our data, fine-tuned data model is very accurate. So with including all these steps, we are saying that our model is very accurate. So this is the process of fine-tuning. Everyone can understood, right? So as of now, we are completing what is fine-tuning and why we need this fine-tuning and how we can process these fine-tuning. That means if we design a fine-tuning model, what are the steps involved in it? Everyone knows, right? So then what is the advantage of these fine tuning models. Just I'm saying simple terms. What is the advantage of these fine tuning model? So what is the advantage means? We can simply say the cost effectiveness is decreased, the accuracy will be increased, and we can use it as a specific task or specific task purpose or specific domain purpose. So that's the reason we are using these fine-tuning models, and we are designing the pre-trained model into the fine-tuned model. And next, what are the fine-tuning? I will, as of now, I explained the generalized solution of the complete process of fine tuning. Then there are different techniques. After that, we have different techniques we can check to fine tune these models. That means we can go in different ways to fine tune a pre-trained model. Here I am showing few examples of fine tuning model. Coming to the first one, that is supervised fine tuning model. How it should be used. Supervised fine tuning model, how it should be fine tune the data. The process is everything from starting of the data cleaning to the data validation and deployment. The process, everything should be same in the fine tuning model. Then how we use these types of fine tuning, where it should comes means it is only comes at the time of which subset of data we are taking, how we are taking the subset of data, the data cleaning and the data formatting part. It is having different techniques. Then we will use these types of fine-tuning models. So for these fine-tuning models, hello, ma'am, can you hear me? Hello.
Yes, ma'am. Yes, ma'am.
Someone is doing writing something, right? So that's the reason I'm thinking.
Second.
So what are the fine-tuning models and where these types comes into the picture? So the fine-tuning models here, where we are creating the subset of data, and at the time of injection of data we are using different techniques of fine-tuning. At that time only we are using these fine-tuning processes, remaining the total steps involved initially. I said the total steps, the validation, deployment, and the parameter rating, everything should be same. Only the subset taking process which we are considered initially, that is only changed in these types of fine-tuning process. The first here I mentioned is supervised fine-tuning. What is meant by supervised fine-tuning means it taken the pre-trained model and it segregates the huge amount of pre-trained data into what is the data we need for our fine-tuning model by labeling the data. It is mainly used in sentimental analysis, text calculations, and question and answer GPTs. Like that processes we are using the supervised fine-tuning model. And the supervised fine-tuning model is also categorized into two categories. One is task defined fine-tuning, and the second one is domain defined fine-tuning. What is meant by task defined fine-tuning? As in the name mentioned, the task defined fine-tuning. So we are fine-tuning the pre-trained model based on the task. So for what task we are doing this fine tuning? So for that purpose we are using this fine tuning model. Example for this task specific fine tuning model is sentimental analysis, and the second one is domain specific. So what is meant by domain specific fine-tuning model. So the tuning model, the fine-tuning LLM will be designed for a specific domain. For example, as earlier I said in few sentences, for the examples of medical, financial, legal, for these domains only we want to use. For medical domain, if we want to use one model, one specific model, so we need to design the domain specific model. For this domain specific model, as I initially said, we need to check the purpose. What is the purpose? We need to design one fine-tuning model from this pre-trained model which will be useful for the medical purpose. And then what we need to do, we need to prepare a data set related to the medical. That means from this pre-trained model generalized data set, we need to segregate medical related data into one subset, and we need to activate this data set only as a parameters, and we will use this data for this fine-tuned model. And what is the use, what is the outcome? If we given any medical related questions, medical domain related questions, then it will give the effective result for these medical related questions. That is coming into the domain specific fine-tuning model. These task specific and domain specific are comes under the category of supervised fine-tuning model. And the second category of fine-tuning model is few shot and zero shot learning fine-tuning model. What is few shot and what is zero shot fine-tuning model? As name mentioned, few shot, that means we are restricting the options present in the generalized model into a specific number. That means it is the pre-trained model initially having billions, trillions of data. So in the few shot, we want to take only 1,000 number of data sets related to the generalized. So it want to give only the results based on these 1,000 rows of data. So that is few shot related fine tuning, which is very efficient, very optimal data of 1,000 from the trillion. Only we need to take anything. If we take, that means in the trillions of data, any number of 1,000 rows if we take, it will not work, it will not give the accurate result. So because of that reason, from the trillions of data, what is the most accurate 1,000 lines, we will take that 1,000 lines and we will use it as a data set, and will prepare our fine-tuned model. And the second process in this is zero shot. What is zero shot model? In this zero shot model, what we did is we are not doing anything related to the data set. We are not fine-tuning anything. Zero shot means zero, nothing. We are not doing any fine-tuning for any specific task related or domain related model. We are using all the data set and we are giving the generalized results to the process. Then why we are using these zero shot means it is used in general level. That means it will be useful to everyone for every scenario. That is the zero shot fine-tuned model. But what we do is we are doing only cleansing of data, formatting of data. These two criteria based on, that means error-free data without duplicates data. We are doing that part only without fine-tuning the data. Just we are removing the errors and we are improving the we are removing the duplicacy. We are improving the readability for the user level. That is the zero shot level. And coming to the transfer learning is also one of the process in the fine-tune process. This is also used to transfer the huge amount of data into a specific task related or domain related. Then it is also comes under supervised fine-tuning level, right? So not like that. How it should be useful means it is specific to parameter efficient models. What is parameter efficient model? So in this parameter efficient fine-tuning model, what we are doing is we are transferring the total data from the pre-trained model into our fine-tuned data model, and we are suppressing, that means freezing. We are freezing the total data set what we doesn't need, and we are only changing the parameters by different methodologies present in the fine tuning. So based on the methodologies, we are fine tuning the parameter level only, not at the complete data set level. What we are doing, the remaining data set means just we are closing the complete data set, and we are closing the complete freezing the complete data set, and we are using the fine tuning mechanism to get the efficient fine tuning model. And the next one is prompt tuning. In the prompt tuning base, we are injecting different prompts to our new model. So based on these promptings for the question, the fine-tuned model will give the result sets. Like this, there are different types of fine-tuning approaches everyone using, and they are trying to get the fine-tuned model from their pre-trained models. And the next one is fine-tuning methodologies. What are the fine-tuning methodologies? Why we need these fine-tuning methodologies means there are different ways here. There are different ways here to fine-tune the process. That means they are using specific strategies to fine-tune the models. So based on these specific strategies, they are
Ma'am, Dr. Anuradha ma'am. Sorry, ma'am. Sorry to interrupt you. Dr. Anuradha ma'am. Ma'am, Dr. Anuradha ma'am, you are interrupting the slides and everything. Please. Ma'am, you can continue.
Sure, ma'am. Thank you. So what is fine-tuning methodologies? Why we are using these fine-tuning methodologies means simply the methodology is a strategy which we are used to fine-tune the complete process. So for this fine-tuning process, we are having different methodologies. So based on these methodologies, we are using different types of fine-tuning mechanisms, and we are completing the fine-tuning process. What are the methodologies comes here is the first one is fully fine-tuning. What is meant by fully fine-tuning? The fully fine-tuning is also called as traditional fine-tuning. That means it is taking all the complete data sets, all the complete data. If we have a pre-trained model and if we want to design a new model, we are taking all the parameters from the initial pre-trained model into a new data model. And what we are doing, we are taking all the parameters and we are not removing any data sets, and we are not cleaning any data set. Just we are freezing the parameters. By freezing the parameters, just we are using these fully fine-tuned model to fine-tune the data set. So in this methodology, just we are taking the data and we are using the complete data into design the new fine-tuned model without doing anything of the data. So in this fully fine-tuned model, fully fine-tuned methodology, mainly we are using zero-shot fine-tune type to create the fine-tuned model. And the second methodology is parameter efficient methodology. What is parameter efficient methodology? As I initially said, we are taking everything and we are freezing some data set, and we are using what we required data set present in the main pre-trained model. For these, there are categorized into different categories. That is parameterized, adapter layers mechanism, LoRa, prompt, prefix mechanism. So what these mechanisms are? Here I am saying few examples. Adaptive layer models. If you see here, adding small layers on top of pre-trained model to reduce the number of parameters. So just we are reducing the parameters. That means if we are in the pre-trained model, we are using 2000 billion parameters. Just we are taking 75 parameters for our fine-tuned models by using this layer, and we are taking this 75 into our main adaptive small layer, and from the bottom layer we are freezing all the remaining 125 parameters. That is known as adaptive layer methodology. And prompt engineering methodology, what we are doing, we are not working on any data present in the pre-trained model. Just we are giving some prompts to the model. We are injecting, without injecting any new data, without moving any old data, we are giving some prompts. So based on that prompts, guidance given to the model, so based on the prompts given to the model, one second. Yeah. Based on the prompts given to the model, it will work. Which prompt is useful to the which question, like this. And the next one, what I said was LoRa. LoRa means lower rate adoption mechanism. That means which is the lower rate resources we are using, and which adoption will give lower cost. That means which parameters present in the main model will give more efficiency and less cost. Based on the LoRa, we are using these fine-tuning model. That means we are converting the pre-trained model into our fine-tuned model. And the next one is prefix model. So we are adding some prefixes to our engaged data set, and based on the engaged data set, based on the prefixes, we are getting the results. All these are adapter, prompt, prefix, and LoRa mechanisms are comes under parameter efficient fine-tuning models. In the name mentioned, parameter efficient, that means we are converting the large number of parameters into short number of parameters to give the efficient results, and to move the parameters into efficient, to use the parameters into efficient way. And here I shared one more example here, that is domain specific fine tuning. That is, as I simply said, so in the supervised model, we are using domain specific subset of data from the pre-trained set of data. So it comes into the domain specific fine tuning mechanism. So all these methodologies are useful to check which type of fine tuning model we need to use to design our fine tuning model. Based on the type of model, we will follow the process and we will get the outcome of fine tuning model. So all these are interrelated. First, we need to check which methodology we should take. First of all, we need to check which type of fine-tuned model we want to design. Based on that, we need to select the methodology, and based on the methodology, in the methodology selection, we need to check what should be the cost we need to put to design our fine-tuned model, and what efficiency we need to design, what efficiently we need to design the model, and how we are using these fine-tuned model. Based on these three parameters, we need to check which fine-tuned model we are using. And if we design the fine-tuned model, we need then we need to move on which methodology should be suitable to our model to convert our pre-trained model into our thinking fine-tuned model. Then based on this methodology, we need to select the type of fine-tuned model. Then we need to follow the process as initially I said, the complete process of fine-tuning till the deployment and validation. We will get the fine-tuned model. And after creating our model and after selecting the methodology, after designing the methodology, selecting the type of fine-tuning model, and finally we designed our fine-tuning model. But while designing this, we are having different difficulties in the fine-tuning models. That are the challenges in the fine-tuning model. What are the challenges? Here I mentioned only major challenges. Those are 5 challenges here, but there are 6 to 10 challenges there, but few are less effective, less impact challenges in the fine tuning process. Few are more impacting fine tuning models here. So first, the data quality. First and foremost is the data challenge. What is the data challenge here and why it is a challenge in fine tuning the LLM? So here what we need to consider. So for this reason, first we need to check how much data we are using for the fine tuning of the model. How much quality of data we are using. What is the data quality and what is the size of the data we are using. How we are getting the effective results from the data. These are the data, these are the outcomes. So for this reason, the data quality is the priority in the fine tuning model. That means if we are using huge irrelevant data for a specific domain, for example, if we want to design a fine tuning model of medical domain, but it is also having some legal related data, then what happened, we will get the non-effective irrelevant result sets. So that is the main reason we need to verify our data quality is very good and it will give effective results. So the next one is computational requirement. So what is the computational challenges we are facing? In the pre-trained model, what we are using is we are using trillions of data sets. So in the trillions of data sets, we are using some subsets of data, I said. So in the trillions of data, if we convert it into millions, it will be useful. If it is also billions of data, then what happened? The processing unit cost, the gigabyte processing unit cost, the data processing unit cost, every processing unit cost subsequently increases. So it is also a barrier for us. So the computational requirement is also main criteria here while using our fine-tuning model. That means already the pre-training model uses huge costness. So for that reason only we are using this fine-tuning model from the pre-trained model. Our fine-tuning model is also costs more, then there is no use of fine-tuning model. So we need to consider this computational requirement. That means the cost decreasing, the usage of resource will also need to be decreased. And the next main challenge is overfitting. What is the overfitting? What is the overfitting of the fine-tuned LLMs? So here what we are doing in the fine-tuning process, the main fine-tuning process are task specific or domain specific. If we are using task specific or domain specific data sets, from the huge data set we are taking a subset of task specific and domain specific data set. What is the risk of that is the model does not generalize the question, it is deviates from the domain or task specific questions. It is unable to generalize the result set, that means outcome, and there are some inefficiency, some generalization missing. So it only gives the domain specific results, not the generalized results. So that's the reason the overfitting is also one of the main criteria we need to consider. And there is one chance here, underfitting also one of the challenge in the fine tuning, but it is not in all cases, because we are subsetting the overall data what we required for our domain specific. If there is, while deploying, if there is any data quality issues came, then only we face the challenge of underfitting. So that is not a major challenge, but overfitting is the major challenge, because we are taking some part of the data, so unable to generalize the data. And the last main one is catastrophic forgetting. That means we are the catastrophic forgetting, what it means. The pre-trained model is a generalized model, so from that huge amount of data model, we are decreasing the data set into few lines. That means millions and billions. So that's the reason the remaining data model details, which is having trillions data, right? Those all data set details compared to this new data set, the knowledge of the remaining generalized solutions, it forgot. So because of that reason, the overfitting is coming. These are the main challenges here. And with including these, there are scalability issues, latency issues. All these challenges are we are facing, but those are comes into small challenges only. So this is the total process of fine tuning. And coming to the next line, that is evaluating of LLMs. So what is the evaluating of LLMs? What are the categories in these evaluations, and why we need this evaluation process? That in this slide we will cover these topics. What is the evaluation process? As earlier I said, after completion of the process, the validation is very important. The evaluation is also comes into the validation process, the validation of newly fine-tuned LLMs to get the better accurate result. So that's the reason the evaluation of LLMs are comes into the picture. Why it is important? So why it is important means, already I said, in the validation process, how we need to validate the fine-tuning LLMs. The fine-tuning LLM, if we give the unseen data, then how our fine-tuned LLM will work. So that's the reason we need to ensure that uh, the fine-tuning model will also effective for the unseen data. At the same time, the main criteria is, if we are using our fine-tuned LLM with the real-world applications, it will also need to assess the accurate result based on the questions given by the user. So that's the reason we need to evaluate as early as possible after completion of the fine-tuning process of our LLM. So what are the categorizations in these what are the categories of these evaluation of LLMs is simply in the generalized way, there are two types. One is intrinsic and another one is extrinsic evaluation. Intrinsic evaluation means already we have different automated frameworks and tools to evaluate these fine-tuning LLMs. Here I tested few examples: BLUE, Perplexity. So these are how these are used means, some are used for text evaluation, some are used for context evaluation, some are used for efficiency evaluation, some are used for semantic evaluation. So all these are used in this intrinsic evaluation. And the second one is extrinsic evaluation. The extrinsic evaluation is human acceptability testing. The human acceptability testing is comes under the extrinsic evaluation. That means some users uses this and they give ratings based on the user given task and what is the result they given, and how the user satisfied. Based on that, we will evaluate the LLMs. with including these general specific categories, there are different categories of the evaluation as well. Task specific evaluation, generalization evaluation, common evaluation, ethical evaluation, like that. What fine tuning model we design, based on that the evaluation criteria will also be changed, but the generalized, we need to include these intrinsic and extrinsic evaluation models. So what we need to do after evaluating these LLMs? So after evaluating these LLMs, how we will get the metrics, that means the results, after how we will get the results, and based on the result, how we will confirm our fine tuning LLM is working well. So here we classified these metrics into two categories: generative tasks and classification tasks. As earlierly I said, intrinsic evaluation and extrinsic evaluation. Intrinsic evaluation is comes under generative tasks, and extrinsic evaluations are comes under classification task. What here they will do, I already explained the propensity, what this tool is used for. If our fine tuning models predicts the next model or the next word or not, that means the sentimental level analysis, that means for this uh, short sentence, what should be the next word? Uncompleted sentence, what should be the next word? So semantically, grammatically, it validates our fine tuning model results. And blue, so it how it validates, how it validates means based on the result given by the fine tuning analysis, and what are the previous results of the generalized LLM model. Based on these two, it will decide which how accuracy our designed model is. And coming to the classifications, so in the classifications, that means human, based on the human accuracy, they are checking what is the proportions of correctness, how accurate the result is, and is there any unethical data is coming from that. Based on the human ratings and human what we say human ratings, it will decide how our fine-tuned LLM will work. And evaluating bias and fairness, that means by only by using our generative tasks, that means by using tools and by using our own testing, we are not confirmed our fine tuning LLM will work. It will also need to check the human challenges and human facing challenges and human rating also. And after designing also, we need to check, is there any ethical concerns present in the fine tuning LLM. That means it is giving any gender biased outputs, or it is giving any inappropriate, that means if there is any sensitive words are there, it will give any insensitive outputs. We need to evaluate that as a main concern. And also how it will work for the real world applications, it will give accurate results or not. And in we are having different regions and we are having different cultures as well. For all the cultures, for all the demographic priorities, it will give the equality, it will give equal output or not, we need to check. And there is any unparliamentary words present in these, and there is any unbiased techniques used these fine tuning mechanism, we need to evaluate all these before confirming our fine tuning mechanism will work properly and will give efficient results. And if you consider one case study of fine tuning of LLMs, I mentioned changing the chat GPT for the sentimental analysis. So what we need to do is we want to design one fine-tuned model which will be used to give movie reviews. So for this process, what we need to take? We need to take the data set completely related to the movies. In which theaters, in which places, which theaters are present, in which theaters, in which movies are present, and based on the movies, how many tickets are sold, and how long the data, how long the movie will run in the theater. All these data we need to segregate, and we need to create the data set, and that fine-tuned data set we need to use in our fine-tuned model. And based on these pre-trained general set, we need to get these data. This data we will call it as sentiment analysis data. This sentiment analysis data we are using in our fine-tuned data set, and we need to perform different test cases on this, how it will give the result sets. Then we need to do the evaluation process, and we need to compare the pre-trained model with our fine-tuned model. What is the result set before and what is the result set after? And what are the advanced fine-tuning techniques we are using here? We are using different types of fine-tuning techniques. I already told, right? The most advanced techniques are active learning. That means what we need to use most informative and most actively selected data and most efficient data into our model, and we need to use that data. We will get the effective learning. And self-training models, already I told, transformers are used for self-learning. So in the own data only, it need to retain their data set, and it need to retain the outcomes from the questions given by the user. Few shot learning means we need to minimize the data, and we need to use the data set for the fine tuning technique. And what are the best practices in fine tuning and evaluation? As from initially we are discussing, right, the data should be more effective in the fine tuning data model to get the accurate result. So that's the reason we need to use high quality data. The data should be cleaned, the data should be error free, the data should give the relevant to that. If it is a domain specific, relevant to domain specific. If it is a task specific, relevant to the task specific data. And we need to check there should be any overfitting. That means if it is completely closing down to the generalization results, then it will not work. So it gives 50-50 chances of generalization also if we use the fine-tuned data set. And also the main criteria is it will work for the real world data set, and it will need to give the accurate result and realistic result, as we mentioned and as we validated for the task specific data sets. How we will get the task specific data set will result, the real world data set will also need to be results in the same format. And how the fine-tuning LLMs and evaluations get improved in the future as well. There are more techniques we are using for the fine-tuning, and more methodologies also we are using in these fine-tuning mechanisms. So in these future trends, how they are going forward is the efficient fine-tuning. We are using the efficient fine-tuning, that means which has less cost, which gives accurate result, like the parameter efficient methods. Parameter efficient methodology and parameter efficient fine-tuning model is there, right? So by using this technique we will get efficient results, and we will get less cost. So because of that reason, it will improve the increase the usage of these parameter efficient fine tuning model in the future trend. And bias mitigation research is also need to be very accurate to give effective results and unbiased results while validating the fine-tuned LLM. And multitasking learning. So as initially said, we need to overcome the overfitting challenge of the fine-tuning mechanism. In the overfitting challenge, what we have, we are unable to get the generalized results. So then it does not work for the generalized results. Means it is only specific to specific concerns only, not all the concerns. So it will not work. So our fine-tuning model will work for the multitasking capability as well. That means domain-specific results with including few generalized results as well. So thank you, everyone.
Thank you, ma'am.
Is there any question?
1 minute, ma'am. I'm giving permissions. Dear participants, you can unmute yourself and ask your questions. Sorry. Participants can now unmute yourself and ask your questions.
1 minute, madam.
Yes,
madam,
yes, sir.
Actually, suppose I would like to design
1 minute, sir. Sir, can you please switch on your video, sir? We'll take one.
Okay,
photo.
okay, no problem.
Please. Thank you.
Madam, 1 minute. I would like to. That is, I would like to design one model. That model can be able to recognize each and every sign language, and I would like to convert into all the languages, whatever the natural communication languages. But in that time, if I will use that is, I need to use that is LLMs to design that one. Then in that case, how far that is a few short learning and zero short learning, is it suitable to train that one in fine tuning purpose? Madam, are you getting my point or not? Hello?
Ma'am, Durga Devi, ma'am.
Madam. Durga Devi, madam.
Hello.
Hello?
Hello.
Yes, madam.
Yeah.
Yes, madam. I have asked one question now.
Yeah, tell me.
No, actually, I would like to design one that is one sign language that is recognition purpose.
Okay.
So in that case, then again, whatever the signs are there, that signs I need to convert into all languages, not only one specific language. I need to convert into Telugu, English, Hindi, Marathi, all these things languages. Okay. But in order to train that one, it is not simple. So yes. I will use that is LLMs. But LLMs, whenever I am going to use that is to train my model, how far it is suitable to train my model zero shot, few shot? Is it suitable, or I need to take any other?
Yeah, that I am saying from initial onwards. We need, based on our requirement of the fine-tuning model, we need to check which methodology is suitable for us. So if we want to use multilinguistic model based on the signs, so if we take the zero shot pre-trained model will take all the data, so it will be suitable. If we take few shot model, the few shot model will be limited to prescribed lines of data only, so it will not be useful for multilinguistic data. So that's the reason if we go with zero shot mechanism, it will take all the data set completely and it will be useful. At the same time, we will check for other supervised mechanisms as well, which will be more suitable for us.
Okay.
So if we want to check less cost effective, we will tend to parameter efficient within the zero shot mechanism as well. So what happened is the pre-trained model completely taken the zero shot mechanism. Zero shot tuning model, what it will do, it will completely take the total data present in the pre-trained model and it will based on the prompt basis, it will check the data. And if we use parameter efficient mechanism, it will feed few parameters which will not be useful for our model design. So then it is having huge amount of data, but the parameters will be minimized, so the cost will also be reduced. I'm not getting your voice. It's breaking.
Participants, any questions? Or otherwise, can you please switch on your videos? We'll take one photograph, please. Participants, please switch on your videos. Thank you. Sir, Rambabu sir, done?
Yes, ma'am, done. Okay.
Thank you, sir. On behalf of the entire organizing team, sir, ma'am, I would like to extend our heartfelt thanks to Durga Devi Jami for gracing us with his presence today. Your valuable insights and time have made a significant contribution, ma'am. Thank you once again, ma'am, for joining us, and we are ma'am for your generous support and for being with us today. Thank you once again. So we'll take one small break. Participants will take 5 minutes break. Later we'll start next session. Meanwhile, in the verse, I want to announce you that the last we are going to conduct one test. The e-certificate, based on the test only, the e-certificate shall be given to those participants only, and minimum you need to maintain 80% of attendance. Okay, please have a short break. We'll meet you after 5 minutes, please.
Thank you all. Thank you, ma'am. Thank you, everyone.
Thank you.
Bye.
Hi, good evening, everyone. Am I audible?
We'll start, sir. Just check your slides, sir, whether it is moving or not.
Okay. Yes.
Yes, it's working. Thank you, sir.
Okay. So I'll share my screen again and we'll start.
Participant will start after 3 minutes.
Okay.
Hello.
Okay. Welcome back, everyone. We are now ready to begin session 2 of day 3 of our FDP on revolution of large language models. Now I want to give the mic to Ms. Shanti Priya ma'am to introduce our honorable guest of session 2. Over to Shanti ma'am.
Thank you, Dr. Anusha. Shaurya Kuchal is the CEO and founder of ATAL Solutions LLP, an AI startup based out of Mumbai. 7 years of experience in building AI solutions. At ATAL, the primary focus is towards enabling organizations benefit from AI adoption. He introduced AutoClarity, proprietary enterprise AI platform, at AI Day Mumbai in 2024, through which he implemented advanced AI solutions to create customer personas, automated form filling, and automated call center audit reports. I would like to invite Shaurya Kuchal of session 2 of today's session 2. Over to Shaurya Kuchal.
Thank you, Professor, for the introduction. Uh, Good evening, everyone. Hope I'm still audible clearly and my screen
Yes,
is
yes, sir.
visible to all.
Yes, yes, sir.
Thank you. So today I'll be taking upon a very important and interesting topic in terms of LLMs, and this is also one of the topic that is most frequently implemented on the industry side of it. There has also been a lot of theory researches, theory papers published. I will also be covering few important topics around the topic. As a request, I see very high volume of participants, but I would still be very interested to know if there are any questions that arise throughout the session, and would love to know either directly you can voice out, or if someone can also type in into the chat if there are any questions. Would be very happy to take discussions from that also. And I've been instructed to keep a good time on good start on the watch also. So we'll try to limit the timing also. Okay, so we'll start. So basically, large language models are neural networks, and they have been trained on very big amounts of data. Data is of the size of few terabytes to up to reaching up to few petabytes also. Depends upon the data models that we are talking about. What we'll be covering today is we'll try to see what all we can do. So quick talk about LLM, why it is working now, how we can perfect it, prompt engineering, techniques, advantages, problematic areas, and if possible, if time permits, I would also want to take up on a demo session on ChatGPT, which is simplest to use and everyone is familiar. If not possible in this session, I would be very happy to take this up in the next session. So the LLMs that we are referring right now, when we say LLMs, I'm sure everyone has heard about ChatGPT, Llama, Mistral, Falcon, Bhashini, AI for Bharat, Powered Well. These are all general purpose LLMs, which means that they are domain agnostic. Their data and the expectation from the model is not to be a master in any one specific domain. So it is not a medical expert, or it is not a supply chain expert or an IT expert. It is just a general purpose expert, which has gone through tons and tons of book. So for a less experienced person, ChatGPT is also an expert in everything. But if we hand it over to probably the professors right now, they can very easily find out where ChatGPT limits in terms of knowledge and understanding of an advanced engineering topic. So LLMs, specifically general purpose, are trained on very large corpus, and they are the benefit that LLMs have right now is that they can retain
Not
the architecture.
audible, sir. Saurabh, sir, can you speak loudly, please?
Hello, is this better?
Now it is fine, sir. Now it is fine.
Okay. So I was saying LLMs have the capability to retain large memory context. So we can feed in entire set of books to LLM and query LLMs based on it. LLMs are not new. They were always available as an idea or in theory, but recently they have been implemented also. Another parameter that is specific and unique to neural network also extends to LLM, which is they have billions of trainable parameters. Now, one parameter could just focus on gender diversity for an organization. One parameter of evaluation of a candidate while hiring them could also be in terms of their graduation marks, post-graduation marks. But we could list out 10 such parameters. Imagine an LLM utilizing 1 billion parameters. It will include everything. It will include its height, past records, ancestral performance, anything. It first standard marks, second standard marks. It has so many capacity, right? So billions of trainable parameters on a implementation side, they give availability for the business people to capture very fine, minute features, which could be overlooked by most other traditional methods. And the key on why everyone right now wants to learn LLMs and defines that it is going to be an important aspect is the reasoning capability. So researchers over the years, when they started off with BERT and transformer models, they have improved the reasoning capacity of how a AI model will work. So right now it is on the mimic stage, and it is expected in upcoming decade or so, it will also surpass the human reasoning capability. Right now it does not surpass. Okay, I'll go to the next slide. So LLMs, why are they working so well right now? Because they work on a very wide range of language tasks. Language tasks which were earlier very specific to NLP experts are now in hand of everyone who is confident and who has the experience in development, not just NLP. Who can think and reason, LLMs can build to some extent very good and well suited NLP solutions. The second is the rise of open source LLMs. So in before ChatGPT 3.5 became a sensation, a lot of LLMs, not okay, a lot of language models were available in the market, open source, but they did not have the reasoning power or the common sense to answer any question. With the advent of ChatGPT 3.5, we also have seen a rise of open source models such as Mistral, Llama. Llama has almost 12 models live now, with the latest one coming up just 20, 30 days ago, 3.2. So this has enabled, and we have seen a consistent drop in the system requirements, while in parallel seeing an improvement in the performance of LLMs. So before I actually start with the prompt engineering, I want to ensure that everyone who were present in the call, 200 people, can actually understand very basic level of how LLM works. If there's any question over here, I can take a pause for a minute and then start continuing with the next topic.
Sir, questions will
At the end?
last at the end, sir.
Okay.
Please
Okay.
continue your
Okay.
session.
Okay. No problem. Thank you. So how LLMs work? This is a three-step how LLMs are trained, and I'm not talking about using Llama or using GPT, but at a broad level, how GPT is created or how Llama is created or LLMs are created. So there's a first step in training is it has to know how to respond to a query. So if it is, because LLMs are essentially neural networks which works on mathematical process calculations. If they receive a text, it does not understand what is that text. It only has, to some extent, a mathematical representation of the text. So it is given on how to respond to a text. A very common example for understanding is dash is the capital of India. So the dash is model is trained to explain that something is the capital of India. Now, what is the capital of India is the answer. So right now, in the first step of training, neural network first has to identify what it is expected to do. So it is first feeded with answers that New Delhi is the capital of India. Similarly, there are other such trainable fill in the blank answers which are given to the model to explain it on what is expected from the model. Then the second part of the query is where it is given similar problem prompts, similar training data annotated, and it is asked to understand the query and respond. So if it is given dash is the capital of India, and if it is given that dash is the population of India, so it gives two different answers. It does not mean that in both cases it will either respond with 1.4 crores or 140 crores or with New Delhi. So understanding the query becomes the second. To understand the query, there are methods in NLP which help you identify the central idea, the subject, predicate, or other aspects, parts of speech, POS of the query. The third part is where actually it is differentiated from the existing NLP models, is where it is able to use a re-ranker. It can extract similar or relevant answers, then it runs through it again and assesses which ones are the relevant answer, and those are passed. So this is a three-step building process of LLMs, and these are critical to understand because these also depict how LLMs can be trained or about their behavior in response to a query. So if so why this is working now? Very interesting research has been published recently. LLMs can are nothing but an extension of very well architectured LSTMs, or long short-term memory models, and which indirectly were an extension of RNN. So a research has published that if we train LSTM on very long data, big data, it will also give good results. So the crux is not about ChatGPT has revolutionized everything. It has, but the crux is that the transformer model that was introduced slightly before GPT took around the world, it is improving. And the computational power that is now available in the market, everyone has either used or is aware in the AI domain about NVIDIA and its GPU. It is enabling all of us to utilize it. So these are the two, three main reasons as to why LLMs are working right now. And plus, we are all have transitioned from a physical or an offline copy of the data to a digital or an online copy. This also makes sure that all of us have more data availability, more data to query, which is why this is increasingly becoming more important. So perfecting LLMs has about 6, 7 approaches. We divide these into 3 approaches. First is the most used or applied approach. Second is a very innovative approach, which was introduced by Meta specifically for LLMs. Third is towards perfection and fine tuning, adapters, quantization. In today's session, I aim to cover the first part, which is the most used prompt engineering. So prompt engineering, all of us have used ChatGPT, and everyone over here is an expert in prompt engineering in one form or the other. In prompt engineering, we have also, these are few questions that I have seen as the most common questions that we feed to ChatGPT. So what questions can be asked in exam from this topic, or explain this topic to me as a 5-year-old. Now, when we are seeing that we are referring to this topic as a pointer, this is nothing but, if we remember from our previous slides, the example of fill in the blank method of training an LLM. So an LLM was already trained to answer questions of this format, and it runs basically on. The second question that is mentioned is, what is the best excuse for missing assignment submission? Write like an engineering student. Over here, there is no fill in the blank. Over here, it is expected to understand the topic and create an answer. And there could be an extension which says that you also give me a list of ideas which promote healthy lifestyle and suggest the best ones for senior citizens. Over there, it would list out internally within itself as an intermediate result. It would list out the ideas for healthy lifestyle and re-rank it. Then create a better output. So all of these are happening in parts, one by one. And although LLMs are very intelligent, we say they are very intelligent, they are experts, but this is all in comparison to the previous generation of language models which we have seen. So yes, LLMs are smart, but we still should give them as small task as possible, dividing individual tasks into very, very smaller sub tasks which are independently solvable. Okay. Now, prompt engineering has many ways in which we can build a prompt. Uh, Prompt engineering requires a lot of grip on English language, creating very precise uh, prompts using defined words and approaching it as close as possible to the LLM training model. Now, why this is difficult? Because very few models, LLMs, have actually open sourced about their training the environment. Very few. And most of those have very less strong reasoning capability. So we try to simplify our expectations from LLMs. I'll be talking about four very popular and very strong approaches, intelligent approaches on utilizing LLMs. The first is least to most. So instead of asking LLM, let's go back one slide. Yeah, so instead of asking what is the best excuse for missing assignment submission, write like an engineering student, I could, and I'm sure we have also seen, we could write as imagine that you are a engineering student. This sets the context for LLM. Then, and this is all part of one single prompt. Then we go out and we say that because you are an engineering student, then you mention which subject it is. Then you say this is this topic of assignment that was to be submitted. And then you say, now you list out what would be the most relevant or one of the best excuses possible. Now, instead of writing, expecting it to give out direct answers, if we decompose the problem into simpler steps, it gives out much confident results. On ChatGPT, if we directly ask it long open-ended answers, for example, if I just ask what is the capital of India, it is one single answer. It will every time return the correct answer. However, if I say to choose between two brands, very well-known brands, it will give me pointers of suggestion. And if I probe it, no, I want an answer, it might differ in responses if I run it twice or thrice. So the whole idea of prompt engineering is, and this happens because neural networks are very, very random in nature. Neural networks have a randomization seed at the beginning, and all parameters output are dependent on. With prompt engineering, one of the critical evaluation metrics for prompt is also that we are able to see if the results are consistent or not. So if I have asked what are the brands that are better than this or which brand is better amongst the two, it should be able to consistently say brand A is better or brand B is better. And if it has been asked, it should also support with the reason. So least to most is one of the good approaches. A better version of this is also self-ask prompting. Wherein if I have to derive something, if Ram has 6 pencils, Shyam has 10 pencils, what is the total number of pencils they can give to Abhinav? In that case, it is continuously asking itself what could be the total answers. So if it says how many pencils Ram, it is intermediately asking till the final answer is achieved. This could also be a list of 10 people giving, exchanging gifts or pencils. In that case, also self-ask prompting is a very good approach. Not the best one, but a very good approach. Yeah. Chain of density. Now, imagine we have to summarize an entire newspaper into a single page of sheet of A4 size. At that point, we might start with adding headings from starting from page 1 to page 10, and that would probably fill up our entire page. Now, if I request one person to again write the summary or again add details, just fill out the entire page in as much information as possible while covering the entire topic. In that case, someone might start with writing the first page heading first, followed by a very small one liner or a 4 5 word explanation about the heading. They might not do the same thing for the last page heading or the intermediate page headings. This explains that while my previous page was of A4 size and it had 40 headings, 40 lines, the new summary that I'm creating now, that will also have 40 lines on the same page, but it will also contain a sub point for each of such topics. So if you see on the example that has been mentioned, that I've taken as a reference from the original paper, chain of density prompt is what all is a missing entity and how to create the summary. So if we see, it has written create a summary which is 4 to 5 sentences. It creates a summary. Then it adds more and more points, what all things were missing. So it continuously updates the previous input while maintaining similar output size. This kind of approach is very helpful when we want to create specifically large document summaries and where the summary size has to be less. So one good example of this use case is survey forms, where a product is being surveyed about its quality or usability from users, and they give out different inputs. In that case, we could start with the problems listed by the user. Then we go on and say, was this problem a manufacturing issue or a usage utility issue? Then we could go on and say, was this related to XYZ part? Then we could say, was this from the previous batch or the new batch? So it keeps on adding more and more information. We could also use the previous approaches to create a very crisp summary and the final output. But the problem is, like we started in the beginning, LLMs will need simpler subtasks. If at the beginning I ask a very complex summary to be expected, it will create hallucinated outputs. Whereas if I start with very generic, simple topics, which we know it is readily available, directly available, nothing derived on the first output, and then for each such output, it will derive continuously. The quality is maintained, and hallucination is a very less risk. Now, chain of thought is a is actually a superstar in the terms of prompt engineering. It is very important to know how chain of thought works, and it is very important to use it correctly. So, in terms of chain of thought, let's say let's go with this example. So let's say Roger has 5 tennis balls. He buys 2 more cans of tennis balls. Each can has 3 balls. How many balls does he have now? So the answer, this is the training part. The first one is the training part. This sort of training is not uh, actually training, it is implementing a suggestion to describe how the output could be achieved. So it says that this is question, this is the answer. Again, this is a very complex task because we have to do 2 into 3 plus 5, which gives 11. But for it, It could say anyway that, okay, I would find a pattern based on some random thing because it is working on 1 billion parameters. It need not follow the same logic that we are doing. And with that in place, it could give out different answers. The model output, if the uh, cafeteria had 23 apples and they used 20 to make lunch and bought 6 more, how many are there? It says 27. So it is not working probably because it is too complex for the model to reason this or how to achieve at this time. Now in this case, instead of breaking this up as one question, one answer, what is done is we say, this is the question, this is how we achieve the answer. Like how we were taught in the schools, LLMs are taught in the same way. We were taught B comes after A, C comes after B. So instead of saying that you recite A, B, C, D and then getting abrupt answers, we teach it to follow certain logics, to follow certain sequence of pattern, addition, multiplication, and then we come to the answer. So over here also we know Roger started with 5 balls, 2 cans of 3 tennis balls, each is 6 balls. So the total is sorry, 2 cans of 3 tennis balls each. So the total is 5 plus 6, 11. So now it knows with reasoning power why, what were the input parameters, what values have to be utilized, how they have to be utilized, what calculations have to be performed, and what is the final answer that is to be submitted. Now, this could also be, there could also be an extension of, I want the answer to be written in words, which means I want it to be written as ELEVEN. And assuming the model is giving 11 as the output, I could also use this logic to say, since answer is 11, I write it in words and reply ELEVEN. This happens very good in terms of prompt engineering. And as we see, this is also, snippet is also taken from the original paper of Chain of Thought published by the authors. As we see, the output now is the cafeteria had 23 originally and they used 20 to make lunch. So now they know what is the balance. So now the LLM is focusing not on the output, but it is focusing on counting the available balance of apples. And then they bought 6 more. So then now the available balance is 3 plus 6, which is 9. And this is the answer. If I had added another layer of mentioning that they bought 6 apples and 10 oranges, then also because it is able now to differentiate between apples and oranges, and it knows it is tracking the balanced number of apples it has, it can very easily answer 9. Okay. This is on the theory part of the prompt engineering. In theory also, there are 2 parts to this. This is on the research paper side. Now we will go towards on how this is sort of implemented, but in theory. So to implement this, we are referring to this word again and again, chain of thought, chain of density. So what exactly is this chain? As we can probably understand from this example also, the chain of thought over here is that LLM is able to question it, what it is looking as an output, what it has been given as an input, and what are the few variables that it has to track throughout the cycle, and what is the cycle, what are the set of operations it has to perform. Over here, it has to maintain the balance. To maintain balance, it has to do subtraction or addition based on the scenario present, and then give it out as the output. Now, chain of thought over here is internal, and these are all separate independent prompts. What happens when we want to implement very big complex tasks? These tasks that are mentioned over here probably will never be given to LLM because they are too simple and cost ineffective. However, if I want to say that you have to summarize emergency manual and place it on a placard at different locations in an institute, LLMs are very handy because they can not only put them on a summary level, they can also translate it. New models with multimodal output can also create graphic imagery. So what exactly is this chain that we are referring? In structured programming, similar to what we have as a recursion thought, we have recursive models, recursive calling, which is being used in factorial and other such very simple problems. Chain of thought could be an extension of it. So first, I would like to explain what exactly is the chain that we are referring to. So there are many types of chains, and there are very specific use cases of each and every chain. Sequential chain, router chain, and self-stabilizing chains are few that are very popular and very actively implemented. So what happens over here in chain of thought? So if this was a much more complex problem, let's say this is about a person making a real estate purchase or a decision that a business head has to make based on the custom consumer buying pattern. In that case, in that case, we want it to say what is the customer buying pattern, in which locations is this pattern, or we can say what is the pattern per location. For per location, what is the average basket or cart size? And finally, what is the click-through rate? Now, understanding these parameters or extracting these parameters from not a structured database, it will raise questions. It will raise thoughts on how we can implement this because this is going to be multiple levels. Another example could be wherein we want to see what is the process being followed for any specific manufacturing. So first a die cast is created, then assembly is done, then paint is done, finally delivery is done. To think of these processes as independent executable logical blocks. Each chain will contain chain of thought prompts or could contain chain of thought prompts. It could also contain chain of density prompts or other such approaches. So basically each chain will have its own set of prompts, and in any format, how we want to utilize those chains, we will attach it. So a chain in a simple term is similar to functions that we use in structured programming. It could be anything, and we own how we want to set up. For the ease of developer, there have been standardized chains introduced by independent library owners like LangChain or Llama Index. But this does not mean that this is the only way to implement chaining. Chaining can be implemented using these quickly, but we are always free to implement it in whatever way we want to. So the first one that I'm referring over here is a sequential chain, which means that what in one input, it processes some logic. There's a prompt that happens over here, lots of details that goes in over there. Final output is derived. From that output, we can either feed it to the next chain if we want to continue, or we could also take this up as the final output and save it. This is similar to what is happening over here in chain of density. So if in chain of density, if the first output is a broad level summary, we pass it to the next chain of prompt and we say in that block, we say that add more details. So we could add more details. Let's say if I were to study, I would capture more details with respect to IT or an AI domain. If someone else who is an artist who would be interested more towards it's their own domain, social worker would be interested in their own domain. So we could create norms specifically depending upon what project you are doing, who is your stakeholder, to make the content more dense. And this could be a recursive way, which means it could follow chain 3, chain 4, chain 5 continuously till the time you are satisfied with the output quality and save it as an output. The second chain approach is a router chain with a major difference over here. The if condition to decide if I want sports or if I want arts or if I want other such profiles, it is managed by us as a simple if else condition. But think of condition where this if else is not straightforward. What if I was tracking a person's digital footprint on my website or on Amazon? Think of it from Amazon perspective. If Amazon has to identify what users bought after they have written a review for apparel, did they purchase a kitchen appliance or not? These are very complex rules because there is pixel ratings, this is uh, Google tags that have to be followed, analytics tag, so many other things. So this is just an example. So in such complex situations where AI is also required to identify if this is going to be for the art as an output or for sports as an output. In such complex scenarios, we can also utilize AI, we can also take LLM's help in deciding what is the correct chain to be followed. So if it gives an input, and we can also say that this input is two part. First part could be the actual input raw data. The second part could be the employee ID or the stakeholder name or anything. Then we know or the other parameters. So it's usage or demographics or other such things. Then we could also utilize that because this is the input, this router chain identifies different conditions and triggers sequential chains or other such complex chains in its own. So router chains are basically intelligent chains which also take care of complex uh, division logics in terms of split logics. Okay, self-stabilizing chain is a very new approach of building a chain. This is, I think, April 2024 is when I think the paper was also published. And this chain is basically an extension of the generative adversarial networks method of working. If I can cover, okay. So generative GAN networks, generative adversarial networks, basically had a rewarding mechanism wherein a generator and encoder and generator were rewarded if independently they performed well in their own tasks. Similar method is followed over here. Instead of us verifying the output, now the output of prompt chaining, the chaining approaches, still depends on what is the performance of independent prompts, the ones that we have discussed. So it could also create hallucinated options, answers, could also create wrong factual information and other such things. So as a process to reduce the errors in final output and reduce the number of training approaches, because unlike the previous image models or language models, LLMs require very heavy training and very heavy amount of uh, annotated data. So we ask LLM to give an answer, and then we ask LLM itself to check if it is correct or not. And if it is correct via the rewarding mechanism, we give it a positive input so that it preferences giving correct answer more frequently than incorrect answer. So this is on the chaining aspect. A major drawback of any kind of chain, unless it is not till the time it is dependent on prompt engineering, is
Sir, can you please speak a little bit louder, sir?
Hello?
Sir, can you please speak a little bit louder, sir?
Hello?
Your
Hello?
voice. Hello,
Hello?
sir. Sir.
Is this better? Is this better?
Okay.
Not better. Is this better now?
Now it is okay, sir. Thank you.
Hello? Is this better now?
Yes, sir, it's audible. You can continue.
If my voice is not very clear, I can turn off the video if that is required and I can continue, or if I am audible, I can speak slightly more louder also.
You can now. Audible, sir, you can continue.
Okay. Thank you. So I will just very quickly reiterate on the self-stabilizing chain. The reward mechanism in the self-stabilizing chain is similar to what was used in GAN networks, and it gives out positive feedback where the LLM, so LLM itself cross-checks how the outputs are created and if the outputs are correct or not. So for LLMs to see if the outputs are correct, it again requires a prompt and a correction mechanism to know, but that is far simpler to check and can be built within the self-stabilizing chain. This is also one of the extensions of the above two chains, but this reduces the manual verification process for the output and improves the overall output quality. Now, irrespective of any chain that we are using, sequential chain, router chain, or self-stabilizing chain, the, the problem that is consistent with prompt engineering is that it requires a lot of knowledge and a precise, crisp understanding of LLM working. Single word here and there could change the entire meaning of the output. So a good way to solve this is an innovative process that was introduced by Meta in 2021, and that is called RAG. So in RAG, we have a model that searches for relevant parts of the documents across the set of documents, retrieves those documents, retrieves the part of those documents, and then then a LLM is required to generate the answer. So, for example, if we were required to answer any simple topic, let's say what are the topics that I have covered in this session, or what are the topics that are part of the curriculum, then it would go through the entire curriculum mentioned in the university with 7 or 12 pages which topic is required, and based on the subject that you are asking for, it will only answer from those pointers, it will only answer the relevant one. So this is how RAG is working. RAG is basically retrieval augmented generation or retrieval adverse image generation of results. Like I was saying, prompt engineering is a very good way. It has zero lag in terms of implementation. The moment a prompt is ready, we are good to go. It requires very less or zero annotated data. But the problem is it has very wide parameter sets because the number of parameters is not 8 billion, 1 billion, or 70 billion. The number of parameters is the number of words it is receiving as input in prompt, the arrangement of words, and the tone of words. Similarly for the output format. And because of the very wide space in the parameter optimization, hallucination is also more common. Hallucination could be of a LLM failing to it could also be.
Sir, your voice is not audible, sir.
Sorry?
Sir. Your voice is not audible, sir.
Hello. Is this
Okay.
is this better?
Yeah.
Okay. I'll keep my video
Okay.
on
Okay.
and
Fine.
off between
Okay.
for some
Okay.
time.
Okay, sir. At last, after completion of this session, you switch on your video, sir.
I think I'm towards the end. I think or leads to a lot of hallucination problems. Hallucination could be on two aspects. It could be in terms of failing to supply an answer within the context length where it just now repeats the similar content. The second is where it faces factual hallucination. And if it is asked about, if it is inputted about apples, bananas, and oranges. And if it is asked about what is there in fruit basket, it is possible. It could say answer about also containing kiwi or uh, guava or other fruits. So hallucination becomes a very common problem in terms of prompt engineering, which is where RAG is now an answer, and also the self-stabilizing chain is a very good approach on reducing hallucination. Uh, in short, prompt engineering is more important and relevant for extracting the information, generating output in the required format, sense, or tone, but it does not train the AI model. So if I use GPT 3.5 or 4.0 or LO, I will need to write prompts which work very well, which give output very well. But that does not mean that I have customized my GPT. Okay. Uh, I have completed most important parts of the session. I would want to take up Q&A if it is okay. And towards the end, if the time permits, I have 2-3 more things to cover in terms of what are the tips and tricks that I would want to suggest for prompt engineering. Can we open up the Q&A, ma'am?
Sir, sir.
Okay.
I invite participants. You can ask questions. You can unmute yourself and you can ask your questions.
Sir, good evening, sir.
Good evening.
Hello, sir. Good evening, sir. I'm from Sir Rajkumar from Jain Institute of Engineering, Chennai, sir. Sir, is it audible, sir?
Yes,
Can you
you're
hear
audible.
me?
Yes.
Okay,
Good
sir.
evening.
Okay, sir. My first question it will be there. Is it possible we can create a chain of things, sir? That you are given that some card. Is it possible we can design some of you are given the two possibilities. If possible, we can have more number of possibility we can design for your card.
Sorry, not clear with the question. You're asking if you can design your own prompt?
Yes.
Yes. So chain of thought is a research approach on improving the prompt outputs.
Yes, sir. Yes, sir.
It does not limit on how or what all things we can do. This is still an
Okay,
evolving field. So chain of
okay,
density
sir.
was introduced last year. Chain of thought was introduced much earlier. These are
Okay,
evolving
sir.
things, and we can always customize this and utilize it in our own format as per the project or role requirements.
Okay, sir. So, what is the role of NLP in this area, sir? Either you can stemming or what are
So NLP is
used for this chain of thoughts, sir?
so chain of thoughts should not be confused as an independent topic. Chain of thought is a approach of
Okay, sir.
implementing prompt engineering. Okay.
Yes, sir. Yes, sir. Yes, sir. I understood, sir.
Yes.
But
Now,
if it is possible, you are put that some rag like that. If it is compulsory, there will be no about some what it will be there, where the word must be there. Then it will be coined that one, sir. If you given some prompt, it will be there. It will make it as a tokenizing. Then it will be find out that your things is there. It will be related to some NLP. Then, is it okay or not?
yes. So chain of thought will use NLP. We can
Yes.
all, as a implementation side, we also use NLP to feed the data better. Because
Yes. Yes.
right till the time GPUs are very expensive, the cost of utilizing token, all of these are essentially
Yes.
the charge on this is free or not, but it is, if it is free, then you are locally hosting, which means that
Yes.
the
Yes.
cost is on tokens. So you have to reduce the number
Yes.
of tokens. So it is always
Yes.
advised to reduce the number of tokens, reduce duplicacy,
Yes.
create. So we also do stemming and lemmatization, like you have rightly mentioned.
Yes. Yes, sir.
So
Yes, sir.
they are important. They are important. But the whole
Okay.
point is that if you were earlier restricted by the knowledge of NLP
Yes.
techniques
Yes.
and you knew 5 or 10 techniques, now you
Yes.
need not know 10 techniques. You can manage the similar output with 8 techniques also, or
Okay,
8 step of cleaning in NLP. And this is not just for NLP, this is also applicable for multimodal
yes, sir.
LLMs. It will also work for image pre-processing. It will also
Okay.
work for video correction and other such topics.
Okay, sir. How to differentiate the words, sir? Suppose I'll given the prompt, prepare a question, generate a question. What it will be differ from that LLM, sir? If that we are how do we can train our things, sir? I'll given the same prompt. Both the thing it will be a same answer must be there, but the question it will be differ. Prepare a question, generate a question. How it will
Yes,
be differ,
yes.
sir?
So the nitty-gritty is this very specific words that we have used: preparing something,
Yes.
generating something.
Yes.
There are others also:
Yes.
capture something, extract something,
Yes.
return something.
Yes.
Now,
Yes.
most of these words would, in the sample testing that we will do manually, would give correct results. But the
Yes.
problem arises when we have to scale this up for 10,000, 40,000 instances. Over there, we get wrong
Yes.
outputs. So what
Yes.
I would suggest as a tip and trick that I also wanted to cover, but that would be LLMs are very good at identifying something.
Yes.
Okay, they are not probably very good at uh, replying in the same manner. Okay, so if you ask LLM, let's say you have
Yes.
given a document in terms of auto car report, any report, any
Yes.
car
Yes.
report of the year, and if you say in India, so and if you say what is the best car of Tata as per that document.
Yes.
So it would return
Yes.
back with with 1 or 2 car models, whatever it is. But if you
Yes.
say it, like you were saying, if you rephrase the prompt and you answer, it will give a wrong output or some other output. Instead of
Yes.
that, you also start, what I have as a practice at Upsolve, we have started doing is use flag variables.
Yes.
Like
Okay,
we do
sir.
in structured programming, use flag variables. We use, say,
Okay.
if is Tata vehicle present in the context? If it is, it will say yes. Then you
Yes.
utilize the output. This reduces
Okay.
hallucination approach. You can
Okay, sir.
also do why using WHs. So basically, which is the best car is the output. Then you go on reasoning why this is the best car, what
Okay,
parameters
sir.
were used for best car. So giving it flag variables, flag outputs, it gives more consistent and hallucination free or reduce hallucinated outputs.
Okay, sir. Thank you, sir. Thank you, sir. Very nice presentation, sir.
Thank you.
Thank you, sir.
I invite participants to give feedback in a few words, or otherwise we'll take photos. Now I request all the participants will switch on the cameras and click. We will take 2 to 3 photos, please. Participants, please switch on your cameras. Rambabu sir, you took photos?
Okay.
Just wait, madam. Just wait.
Okay.
One minute, madam. 1 minute. Just wait.
Yes, sir.
So,
Shaurya
Shaurya,
sir.
can you stop the sharing?
Sir, Shaurya sir, can you please switch on your video, please? Shaurya sir.
Stop sharing the screen.
Sir, please stop that sharing and please switch on your video, sir. Shaurya sir.
Should I end my
Okay, thank you.
Sir, you have taken photos, sir. Rambabu sir.
Taken, madam. Thank you.
Okay. Okay. Thank you, sir. So, agent, 1 second. So, first of all, I would like to be on the behalf of the entire organizing team, I would like to extend our heartfelt thanks to Dr. Shaurya Kushal Garu for gracing us with his presence today. Your valuable insights and time have made a significant contribution on this event, sir. Thank you so much, sir. And one more thing, one gentle reminder to all, we have 2 more sessions. We have interesting sessions we have tomorrow. The first one is the applications of RNN and LLMs in real world applications by Dr. K.V. Kadambari Garu from NIT Warangal. And second session was Dr. Sirisha. The topic is the influence of NLP and LLMs on addressing healthcare challenges by Dr. Sirisha ma'am. So please join at time. Okay, thanks for joining. Have a nice day. Bye bye. Good night.
Thank you for inviting. Thank you.
Thank you.